Here is another kind of mechanism you might find in a machine, a linkage. And a linkage is made of rigid bars. They're connected by pins or sometimes sliders like in a locomotive wheel, and you find them all over the place. Now, this is a kind of study called kinematics. I've made a little table here. If you were to be designing something where you were concerned about the aesthetics, the visual appearance, but you were not thinking about the forces, that would be just industrial design, visual design. If you were thinking about a thing that does not move, it's static, and you're analyzing the forces on it, then that's the field of statics, which we study in structures class. If you're thinking about the forces on a thing that is moving, that's a field known as dynamics. If you are just thinking about the motion of the thing that's moving, but you're not concerned with the forces, that is a field known as kinematics. And that is what we are studying when we look at gear ratios, linkages, which we're doing today, cams, which we'll do next time. That's all kinematics. And you might notice this word is very similar to our word for motion picture. It comes from the Greek word kinema, motion, and in English we spell it with a C, but it's all about motion. That's what we're analyzing here. And we analyze it by drawing schematics. If you work for the vice grip company, for example, and you're trying to figure out how in the world do these arms and handles and levers all move, you don't draw the whole thing out as a working drawing with all the shapes. It would be hard to analyze that way. So what you do as a designer is you make a schematic, and that's what you're seeing here on the right, where you break down the levers and the pins to their very simplest elements, and you simply analyze the motion. Now, this schematic does not go out to the shop. This is a tool for you, the designer. But once you have analyzed the motion with your schematic, then you can go on to drawing a working drawing that you do send to the shop. And in this class, we're not going to create working drawings of any of these linkages. We are only going to do the schematics, where we try to analyze the motion of a thing. And here are some guidelines for drawing these schematics. This is out of our book. The basic idea is that you represent each pin, each pivot point, with a circle that's about 3/32 of an inch in diameter when it's printed. You connect the pins with straight lines. Any place where you have a pin that's fixed, it's held down, it's not going to move, you put a thing that looks like an ear. Well, here we are up in the upper right corner. See that? Kind of looks like an ear with a radius top, and then it's got a hole through it. And it has some short hatch lines underneath representing ground. So that's the symbol for a fixed pin. Circles are moving. Thing with the hatching is fixed. There are different ways to categorize these linkages based on their shape and how they move. These are the 4 basic types. A crank is a link that is fixed at one end. The other end pivots, goes around in a complete circle. And you can actually picture a crank literally, like on this crank that's going to lift a bucket out of a well. There's a crank. You find one in a car engine. If you have a link which is fixed at one end and the other end oscillates back and forth, but it does not go in a full circle, that's a rocker or a lever. You see a lot of these kinds of linkages, all four kinds, in various kinds of excavation equipment and earth-moving equipment. So there's a lever or a rocker. It moves back and forth. If you have a rigid bar that moves back and forth, but the pivot is in the middle of the arm, that's called a rocker arm, like that. Here is, these are out of our book, here is a pictorial drawing of a rocker arm. This is what the schematic looks like. You may have encountered a rocker arm in a car engine that is connected to the valves, makes the valves go up and down. A bell crank is kind of similar, except that that pivot point, that fixed link, is not in a line with the other 2 points. And it can be a variety of shapes, but the main idea is it's not in a line. Here's the picture out of our book, a pictorial and then a schematic. We will not draw any bell cranks in this class. And you're quite likely to see bell cranks in various kinds of excavation equipment. I took this picture around Eugene somewhere.